Welcome to the Bioinformatics CRO podcast. I'm Grace Ratley, the editor of the podcast, and this week we're doing something a little bit different. Today I'm going to be talking with our usual host, Grant Belgard. Grant, can you introduce yourself, please?
Hi, I'm Grant. I'm a computational biologist and founder of the Bioinformatics CRO. I started the company almost 3 years ago now.
Yeah, I also know you work a little bit with BitBio. Is that something we can talk about?
Absolutely.
Cool. Yeah, so what's your role at BitBio? What does BitBio do?
Sure. So BitBio differentiates cells from pluripotent stem cells. So I'm head of bioinformatics there, and on an interim basis, head of data management and IT.
So what kind of cells do you guys differentiate? Have you had any success? I haven't really followed much of it.
Yeah, so we have some products on the market. If you go to bit.bio, you can check those out. There are also a number of products in beta.
Very cool. Yeah, so moving on to the Bioinformatics CRO, which is the namesake of this podcast. So tell us a little bit about what the Bioinformatics CRO does.
The Bioinformatics CRO provides computational biology services for small to mid-sized biotechs, academics, and also big pharma companies. Basically, we allow clients to work with bioinformaticians with specialized expertise that they may not have in-house, and also to tap into a broader pool of computational biologists when they simply don't have the resources in-house to successfully tackle projects or to complete those projects in the timelines needed.
So the Bioinformatics CRO is an all-remote company. We started out all remote, but COVID has kind of shifted things a little bit. Have you noticed any sort of change in the workflow as a result of COVID, or has your workflow mostly stayed the same?
So things haven't really changed for us that much, but we have seen changes in the perception from clients in some cases. When we started the company, remote work was still somewhat of an aberration in the industry. Some clients, frankly, didn't understand it. And now everyone does. I mean, I had been working remotely most of my career, well before I founded the company. And so I knew that it worked very well for bioinformatics. But, I had to kind of convince the rest of the world of that. And COVID, although it's been net extremely negative, has accelerated some positive trends. And I do think remote work is one of those. Fully distributed companies have gotten easier to run in recent years. Slack is wonderful. Zoom is wonderful. There are platforms now such as dealremote.com and Oyster HR that facilitate working with people regardless of geography. There are also programs such as Estonian e-residency that allow people to form companies and operate companies regardless of where they live. And I think in the long run, we're going to see very large impacts in the industry. Most people in biomedical research don't work where they grew up. About a third of biotech activity in the US is in Greater Boston. About a third of that is in the San Francisco Bay Area, and about a third of that elsewhere in the US. And you see similar patterns of extreme concentration elsewhere in the world. And that extreme concentration is largely driven by network effects. Network effects are very strong in biotech. It can be challenging to find seasoned executives. So it's easier to start and grow a company in an area where there's a lot more activity in the industry. Geographic proximity promotes serendipity. But the circumstances for serendipitous encounters can be engineered even in an all-remote world, right? So there are programs such as Lunch Club and Growth Club, and many of the local and state biotech trade associations that used to have in-person meetings are now having Zoom meetings. The networking interactions that happen there are obviously different from those that happen in person, but really, I'm not sure that they're less efficient overall in terms of the time that people put into less spontaneous interactions. I think we're moving slowly as an industry to a world where a much greater proportion of people not only work from home, but work some distance from where their company may be headquartered. And their company may well be headquartered in a room in someone's house. I think it won't happen immediately, in part because when people have children who are in middle school or high school and they've really put down roots in say, Greater Boston or something like this, of course, many of those people are not going to want to move. And certainly there are many advantages to living in those hubs. But I do think the greatest hub of the future will be the internet, and people who essentially see their professional lives lived out online. And this may sound weird for something like biotech, where you may think you need people at the bench, and certainly you do need a lot of people at the bench to bring a product to market. But they don't necessarily have to be people working for the company that brings the product to market. I think another trend that will continue to accelerate in coming years is networks of contract research organizations working with small, nimble, virtual biotech companies. And many people will not work for just one small virtual biotech company. They may work for a few. And I think networks will be more important than ever before. I think increasingly networks are going to supplant big companies in the space of innovation. Big companies have advantages. They reduce transaction costs. So if you are at a big pharma company and you want to access expertise in very different areas, you can do that. And you can do that without having to negotiate and sign contracts and so on. And that's great, but there are a lot of inefficiencies you have with large companies that are corrected to some extent with networks of virtual companies and CROs and so on. So you'll either have people paid to do marginal work in order to have them available for and on standby for more important urgent work, or you'll underhire and bottleneck progress. Either of those is a problem. And more importantly, there's been a lot of work done on how innovation is often stifled in larger companies. Disruptive innovation often requires a lot of work to create a product that is superior to whatever the current state of the art is. And it can be difficult within the context of larger organizations to have that sustained investment that's required to really bring forward new technologies. Looser networks also have an advantage in that it can be difficult for outsiders to an area to know who's competent and who's a blowhard. These repeated interactions where you know someone does great work, you work with them at one company, you work with them at a second company, you work with them in a third company, can really move things along. You certainly don't want to have Google be your port of call for finding all the expertise that's required to develop a drug. And so I think these distributed networks with distributed companies will become an increasingly important component of the global biotech landscape, and that you'll see a lot more innovation coming out of these types of companies. And none of this is new. I mean, all these organizations exist, and a lot's been said and written about them. But I do think we'll see a lot more of that.
Yeah, I think those are all really great insights. I think that with the networks, there's a lot more buy-in when you're working in a small company. Everybody feels like they play a bigger role in driving the company forward.
Well, and everyone does play an incrementally much larger role. If it's a team of 5, you certainly have a much bigger impact on the company than a company of 50,000.
Yeah, I know working for the Bioinformatics CRO, I have done all kinds of crazy tasks that I never would have imagined doing. And I feel like I know one concern about working with all of these remote companies is the difficulty with finding that interpersonal connection, because you're not going into the office every day and you're not seeing your coworkers every day. But for me, at least, I feel like more connected to the company because I am one of 5, because there are fewer people, and we do communicate a lot because I have a lot of roles to play in the company. And so, I don't know, I feel like there's more of a commitment to the company, for me at least, and it is more connecting. And I think that's something that a lot of people don't think about when they're thinking about working remotely.
Right. And I think as well, large companies are by nature a bit sociopathic. There's no human agency. Maybe I'm painting with too broad a brush, but certainly with very small, closely held companies, there's, I think, much more of a human element that, frankly, Fortune 500 companies can't ever have.
Yeah, definitely. So, as we move into this virtual world as a biotech industry, as people move remotely, technologies like Zoom have really come to the forefront and they've evolved a lot. Like now I can go to all my meetings as a cat with the cat filter on. But what do you think are some really important tools or technology that'll make this transition easier for everyone?
I think these days everyone is certainly familiar with Zoom, and most people have probably tried their hand at something like Slack. One thing I think is really critical for all remote companies is to create opportunities for people to interact informally, and sometimes to interact around topics that are completely unrelated to their work. Right, the water cooler type conversations that ordinarily happen in an office, and that's because, everyone's a person and relationships are at the core of everything we do as humans. And if you have a poor relationship or non-existent relationship with someone, or maybe an entirely transactional relationship, firstly, it's just a lot more unpleasant as a person. Secondly, when things get difficult, and there are always periods in any company and in any project where sometimes things are hard, it makes it that much harder if you don't have real relationships with the other people who are, working through that with you. So there are tools such as icebreakers.video and so on that give people those opportunities. And even things like the random channel on Slack give people an opportunity to interact informally, to share things that are funny, just to be people. Because I think it is easy by default without, if you don't make an effort, for all remote teams to become more transactional than they should be, right? So you have a meeting on a specific topic, you discuss that topic, the meeting's over, you discuss projects and emails and things like this. Having all your interactions be like that is not healthy and not normal. So I think that kind of thing is often not explicitly addressed in traditional in-person companies to the extent that it needs to be in fully distributed companies, where you can't have these spontaneous interactions occurring in the lunchroom because the lunchroom is your own dining room at home. So one thing we're doing at BitBio that I think is pretty neat is a month where people are running or walking and basically recording that. And as a team, seeing, how far everyone can get. We're kind of most of the way from Cambridge, UK to Spain now, if you add up everyone's distance. And, it's both a way to promote fitness and so on, but it's also kind of a neat thing for people to be able to do together at a time when people generally can't as easily get together.
Yeah, I think that kind of stuff is really cool. But yeah, the social technology is probably what's needed most. Social technology that brings smaller groups of people together, I think is, for me, that's what I would like to see. Yeah, so I know you've had a really interesting path to where you are right now. Let's start from the beginning then. So when you were a kid, what got you into science?
So when I was in 7th grade, I started reading books by Richard Feynman and reading a lot of books about nanotechnology and things like this, and got really drawn in by quantum mechanics and nanotech. They just both seemed incredible and non-intuitive. Then I realized, well, if I want to understand more physics, I need to understand more math. So, I started getting pretty far ahead in that. And really, yeah, I would say from seventh grade on, I was really quite focused on science. I wasn't exclusively focused on science. I mean, I was also very interested in history, very interested in economics. I was a very active and fairly good cellist, but science was what I was most interested in. So the last 2 years of high school, I went to a public statewide boarding school in the state of Louisiana called the Louisiana School for Math, Science, and the Arts. And that was fantastic because they had a lot of college level courses, and even where they didn't have courses, you could do independent studies. So, I was able to do a partial differential equations course as an independent study in high school, which was fantastic. And a ton of programming courses. It's funny, I actually did, learned the vast majority of what I know about programming in high school, not later. That was a really great experience. This is a shameless plug. So there's a foundation that supports the school. So I would encourage any listeners who are kind of moved by what the school can maybe do to check out the LSMSA Foundation. So it's Louisiana School for Math, Science, and the Arts. So the great thing about LSMSA is it provides opportunities for students from across the state that very few of them could possibly have had at their home schools. It really opens doors at a critical time in people's lives, right? So a lot of these kids were 15 years old. Now the school accepts sophomores, but it can be especially transformative, right? Louisiana is not typically known as a state with strong educational opportunities, but actually when it comes to requirements for gifted education and then opportunities like this school, it actually is pretty exceptional in terms of services that are mandated. So I worked pretty hard while I was there. I think senior year, one semester, I took something like 13 classes and the other semester 14, and basically graduated with a ton of college credit. Got accepted to a lot of really good places, but I wasn't really thinking too far ahead about the financial aid bit of it. So I ended up going to Rice as a good kind of compromise, where it was a good school I could go to and I could graduate without taking on any student loans. And Rice punched and continues to punch above its weight in the nanotech space, which was what I was most interested in at the time. So actually, somehow I managed to snag the nanotech at rice.edu email address as my personal email when I started, and majored in chemistry, physics, chemical physics, and biochemistry and cell biology, not just because I wanted to stay for 4 years and see if I could do it, but also to get a broad base of education. For something like nanoscience, it's very, very interdisciplinary. And so it's important to understand, the physics of what you're doing, the chemistry of what you're doing, the maybe biological system in which you're applying it, and so on. And senior year at Rice, I read The Selfish Gene by Richard Dawkins, which was a phenomenal book. And it really helped me realize biology isn't just stamp collecting and is increasingly becoming a field that we can understand through the lens of information and data, and that I didn't need to spend my PhD pipetting, which I had grown to dislike through my 4 years at Rice. I mean, I loved kind of the problems I was working on in the lab, but I just did not want to pipette anymore. And I loved computers and always had loved computers. But also while at Rice, I was very busy working a number of jobs on top of school, so that by the end of it, I was on the verge of being burnt out, I would say, and figured on a lark I would apply for the Rhodes Scholarship and the Marshall Scholarship. And if it worked out, then, that would be great. And if not, I was thinking of, maybe joining the Houston Fire Department or something for a year just to do something totally different. And
wait, the fire department?
Yeah, or I was looking at that, or going to work on a fishing boat.
Wow, I mean, those are very interesting gap year choices.
Yeah.
Did you have any EMS or fighting experience beforehand?
No.
Wanted to try it out. That's so interesting.
Yeah, just something pretty different than what I had been doing for the last few years.
Yeah.
Yeah, I think my parents were not thrilled with those choices, but fortunately for them, the Marshall Scholarship worked out. So And then there was also this NIH Oxford Cambridge program that was still at the time relatively new. And they had a partnership with the Marshall Scholarship. So, you kind of had to put in an independent application and all this. But, I went ahead and did that because I figured it would be, it would make for a more interesting PhD splitting between labs, so that basically in the program, you split your time between a lab or at least one lab at Oxford and at least one lab at NIH. And a number of people had multiple supervisors. So at Oxford, I worked with Chris Ponting, who had been a contributor to the human and mouse genome projects and some other big genome projects, and had been doing a lot of work looking at functionality in long non-coding RNAs. There was a project that they had already discussed doing, but didn't really have anyone to take it forward. Or it'd be a collaboration between Chris Ponting's lab, Zoltan Molnar's lab, who is an anatomy professor at St. John's College, Oxford, and Elliot Margulies at NIH, who worked in the genome technology branch and was doing a lot of work on the tech dev side with this new set of so-called next generation sequencers. They were made originally by Solexa. Solexa was bought out by Illumina. When I was there, everyone was still calling them the Solexa machines, because it was still very early days. And now there are tools that are fairly standard to do all this stuff for you, but at the time you were kind of having to write your own tools to do most of the steps of what's basically automated now, which was nice because you really got to learn the ins and the outs of the technology. I spent a couple years primarily at Oxford, going back to NIH periodically, and then a year at NIH going back to Oxford periodically. And when I was at NIH, met Angel, who was to become my wife, as you know, Grace, because you have babysat for our firstborn before.
Yes.
So Angel was in medical school at the Uniformed Services University for Health Sciences. So it's basically the military medical school. And she was in the first half of med school at the time. So she was based out of Bethesda, Maryland, literally across the street from NIH. If you've lived in the DC area, you'll know that proximity matters because traffic is pretty bad. So my NIH supervisor, Elliot, left NIH to take a job as director of scientific research at Illumina Cambridge. So that was kind of my first experience, I guess, working remotely, where Elliot was gone. People in the lab started trickling elsewhere. And at that point, there was really no reason to go in anymore. You might as well work from home or from wherever else you are. I mean, there were certainly very nice people at NIH, but you could also get in a bit of trouble. I had my internet access cut off for a while once because I had been speaking with my mom on Skype, and I forgot to close it before I went into the office one day. And so they detected that Skype was on, trying to access some port. And I guess it was, banned by NIH policy. So I had my internet cut off and I had no idea why. I was trying to get by without it for a few days. And then finally, one of the IT people from main campus found me and and explained what was going on. But, so it was just easier not to be working from NIH campus. Yeah, so I was basically remote for a while there, and because Angel was moving around every month, because at that point she was doing her clinical rotations, and at USIS, your clinical rotations are at different military hospitals across the U.S. So I was able to spend some time with her. We got to spend some time in Honolulu while she was doing a rotation at Tripler Army Medical Center, where I was writing up my dissertation. So that was nice. Basically, during the week she would work and I'd work on my dissertation, and on the weekends we'd be able to enjoy Hawaii. Basically, I was living out of a suitcase for 6 months at that point. Then I did a short course in Okinawa and then returned to the UK to finish writing up, to finish some papers, basically to get on to the next thing. So after finishing up the PhD, I, flew back to my parents' house where we'd kind of been storing everything. And my parents had been watching Angel's cat. We got the cat, the cat, Lena. So Lena was, she's no longer with us now, but even at the time she was already, starting to show her age. But I basically packed my vehicle floor to ceiling and had Lena in there. And Lena realized that she could open and close the automatic windows, which was not great because at one point we had things flying out on the Texas interstate and had to go and collect that. And yeah, so I made it to LA. I was originally going to live on a sailboat, and then some people down at the marina were concerned about, what the California authorities might think of having the cat, which, as it turns out, would have been perfectly fine. I mean, the weather's very nice. And so for that reason, I got a very small, moldy apartment close to UCLA campus to live in during the week, and did a number of projects that were pretty interesting. So I inherited a project looking at gene expression in the brain in autism, which built upon a previous paper they had published. That first paper was in Nature, then our paper was in Nature. And I think actually is pretty impactful because it was showing, these common changes in gene expression in a pretty decent proportion, basically in most people with autism, which didn't have to be the case for a psychiatric disorder with, at the time, no known neuropathology. There's a bit more known about that now. And certainly there's a lot known about the neuropathology of certain syndromic forms and so on. Yeah, I also did some work in autism genetics. Did some work in kind of comparative neurotranscriptomics. So following up on the comparative neurotranscriptomic work I'd done in my PhD, but here we're looking more across primates. So I was physically at UCLA for a year, and then Angel and I got married halfway through that year, and then she was stationed at Wright-Patterson Air Force Base outside Dayton, Ohio, the following summer. So basically, I walked into Dan's office and told him, "Hey, I'm moving to Ohio, so I can keep working remotely, or I can find a new job." So I kept working remotely. Did that for a year, and then heard again from Chris from Oxford about a really interesting project that he was getting involved with, where we would be sequencing transcriptomes in single cells of the brain. And this was very new technology at the time. I mean, now everyone's doing it. And, we do single cell projects constantly at the CRO, but there was still a lot to figure out at the time. I thought that was really cool because I kind of saw, single cell sequencing is the future, which was true. So kind of returned to Oxford, but this time remotely. It was also part of a large multinational consortium. So that was pretty interesting. We worked with a lot of people in very different disciplines. They were trying to use these data to model things like protein levels in different cells and so on. It's really interesting, working with them to try to figure out how to do that. That was also when I ran out of pages in my passport and had to get more sewn in.
Wow, what a dream to fill a passport. I feel like that's probably on most people's bucket lists.
Yeah, there's actually a CBP officer in Chicago who got to know me because I kept kind of going through his little booth. And there was once where I entered the country twice within 10 days or something. And he remembered the conversation we had the previous week.
That's a way to get to know someone.
I also learned don't connect in Chicago in winter unless you want to have a pretty reasonable chance of spending the night in Chicago.
Duly noted.
So a couple years into that, I heard from an old friend at UCLA who had started with someone else in the lab at UCLA, a company focused on genomics-driven target identification, using a lot of the techniques that I'd used in my PhD and postdoc. It sounded pretty intriguing. At first, they were basically seeing if I could, move out to the San Francisco Bay Area, and the answer to that was definitely not. We were still in Ohio at the time. So then they said, well, maybe you can start as a consultant. And so we did that. And before long, I got so heavily involved in things that it made more sense for them to bring me on as an employee. So I worked remotely, initially in Ohio and then in Florida. And that was very interesting. Definitely, learned a ton about the biotech industry. Learned a lot about AWS. So I had never really done any cloud computing before. And of course, now with the CRO, I mean, we use, and a bit bio for that matter, right? We use AWS all the time. But ever since I was a kid, I got really interested in science and I was thinking about what I wanted to do when I grew up. What I was thinking was not really that I wanted to be a professor, but I wanted to run a science company. And I didn't really know what that meant, but I was thinking, well, science, the company that does science. And it turns out that's actually exactly what a CRO is, right? I mean, you're a company that does science. People hire you to do science. Like, how cool is that? And you don't even have to go and write grants and things. They come to you with here's the problem and here's the budget and go figure it out. So
it sounds like the best part to me. It's not having to write grants.
Yeah,
I've written a few already, and not my favorite thing.
The money comes to you.
Yeah, exactly.
I mean, there are obviously hassles and things like that, like there are with any job. But I was also thinking, okay, my almost entire scientific career had been remote, and certainly at the time it was looking like that was going to be the case indefinitely. So I wanted to get something in place that would be more robust, where I wouldn't be worried about, oh, what happens if this company goes out of business or whatever. So I, basically took some money we had saved up to put into this company so that we wouldn't need any external investors. That was stressful for the first 6 to 8 months until I didn't have to write checks to the company anymore. So that was a good milestone. And yeah, I mean, we've definitely at the Bioinformatics CRO have grown a lot since then. So as you know well. And yeah, we've worked with several dozen clients worldwide. We work with over a dozen scientists, and we've kind of figured out, basically how to run things, how to juggle across all these projects, make sure that people are doing the things that they know how to do well. I mean, I found a big part of that is the opposite of what you may sometimes have happening in very big companies, where you really have to know the strengths and weaknesses of every person, and kind of assemble teams for projects in a way that reflects that.
Yeah, thanks so much for talking with me today, Grant, allowing me to interview you. This has been I've learned a lot about you.
Well, thank you for doing this. Certainly you've spent more time kind of working on the podcast than anyone. Now you're getting a titled role.
Exactly. So if you guys liked this episode, please rate us wherever you listen to your podcasts, and please give us feedback. We'd love to hear from you at podcast@bioinformaticscro.com.